Now let's go through the architecture of the monolithic systems. So in this is the architecture of the monolithic systems where we have a simple browser or and like the users come in from here, and then it goes to the request goes to Apache, and from there reverse proxy or proxy happens, and if it is static it will give the pages from the Apache server itself, and if it is not it will reverse proxy to the application server, and from there it will serve the pages. So again, the application server, which is Tomcat here, it may have various other services built in within a single executable war file, which is like here we have storefront UI, accounting services, inventory, shipping, etc., which may again be connecting to an external MySQL database. So this is the traditional web application architecture, which was like very simple to develop, test, deploy, and scale. Now, this like monolithic architecture is usually like is a very large application which in itself have many capabilities. So all bundled as a single logical executable file. So here in this case, the single logical executable file is war file. The application here exists for several years, like because monolithic is like very old architecture. So here the application exists for several years and hence becomes a legacy application, and it is very complex to fully understand because there is tight coupling, and you cannot even update one component because all other components are tightly coupled with each other. Here the development velocity slows down because the changes in one part of the code base can cause confusion or unforeseen consequences in the application. So whenever a part of the monolithic application is updated, it must be rebuilt and redeployed across the entire environment, which may be dev, production, or UAT, etc. Similarly, when a part of the monolithic is a performance but whenever a part of the monolithic application is performance bottleneck, entire application must be scaled to meet the demand. Now also the changes in the framework or languages for one service may be impacting the entire monolithic, as it may not work in the cohesive way with the components and will likely slow down and expensive. But but uh, but the important thing is like it may be providing some important business function, hence we may just need to maintain this software. So this is always like in the case of monolithic there is a tight coupling of components. Now what are the merits of monolithic architecture? So it is like simple to develop, so the goal here is to just maintain the existing important business application. The goal of the current development tools and IDE is to support the development of monolithic applications. It is very simple to deploy because you just have a war file and you just need to deploy it in the application server. That is, single executable file is there. You don't need to worry about anything. It is very simple to scale to a certain extent. It is because this can be done by running multiple copies of the same application behind a load balancer. So here in our case, what we can do is if we want to scale it, so we just need to create one more Tomcat instance with same war file, and we can have a load balancer which will point to the Tomcat separate Tomcat instances. Similarly, if we want to scale the Apache server, we can have two Apache server and one load balancer which is pointing to it. Now, what are the issues with this? So the main issue is like it is very difficult to understand because it's very complex in nature, and all the components are very cohesive and attached to each other. Uh, it overloads the architecture, and the continuous deployment is difficult. So it has scaling issues in the long term, because when you want to infinitely scale, it is very difficult to implement those things, and it has a long term commitment to the tech stack. Now from this part our microservices come into picture. So it resolves or solves the problem of the monolithic architecture. So it is an architectural style specifically aimed at addressing the concerns of monolith architecture by structuring a system as a collaborative loosely coupling service, as a collection of loosely coupled services. So here what we do is all the services are loosely coupled, they are not tightly coupled with each other. uh, so benefits of microservices are like we can reduce the coupling among the components, and we can increase the cohesion among the components, increase development philosophy. So every component can be individually developed, and whenever they want to update, they can update themselves, and they don't need to worry about other components really. So this is the kind of architecture which we have nowadays for our microservices. So here, like user can come via mobile app or browser, and based on the user, it can go to the particular server. Like here, in case of mobile, it goes to the API gateway. From the browser, it goes to the store web app API. So from here again, the it is routed to various other services like account service, inventory service, shipping service, all are connected to the web. Similarly, via mobile, it is connected to all the components, and all the components have their own independent database here. Now, what are the benefits of microservices is like it allows users of multiple stacks, so we are not stack dependent on each other. We can use the right language or the right libraries, whatever is required in our case for the service or the framework as per requirements. Service can be backed by relational as well as non-relational database based on requirement. Now the services are deployed and changed independently. They are earlier they were dependent. Like if you have one change, it needs to go with the whole new war file. So those things are removed now with the microservices. You can independently update the services. It is easily scalable. Then the other thing is like development release velocity and efficiency can be increased, and there can be more frequent deployments, and that too specific to the particular service. Now, what can be the demerit of this is like microservices increase operational complexity. So you can see how here the architecture is quite complex here, and the operation becomes complex. Also, if you see every service has their own DB. So for the DBs to be synced, it may be it may be a separate issue. Like we need to consider about the eventual consistency of the services. Yeah. Also, as all the services here are having their own network, then so what we can do is like we can make this as internal service, and others as, I mean, not shipping. Basically, you can see say the inventory service, we can make it as internal service, and shipping can be an external service. So the connection and the networking things we have to keep in mind while developing. Now, coming to the again previous our topic, like here we will be comparing our VM versus Docker. So earlier in the old ages, or even in today's, like most of the application in banking and other industries are running on VMs as infrastructure, and uh, here we will come in the case of microservices, we are using containers. So we'll compare both of them. So you can see like the layer here is made up of infrastructure in both of them. And then again, like here in the machine virtualization, we can have an OS, and also on top of that we can have a hypervisor, which can again which enables us to host multiple OS, and then we can host our application. So here like we can in the hypervisor layer, we can have below it an OS layer or not, it depends again. But here the majority of the things in the case of Docker infrastructure is that like if we don't require any hypervisor, and the single operating system can host various applications using container technology, and it is very lightweight as compared to the VM, and it is very efficient and fast. Now we have seen like this term called hypervisor. So what it is like, hypervisor is a computer software, firmware or hardware we can say, which creates and runs virtual machines. So this enables us to create separate virtual machines. A computer on which a hypervisor runs are or more virtual machine is called host machine. So this machine can be called as a host machine on which the hypervisor is running, and each virtual machine which we have installed on top of that can be called as a guest machine. So all these complexities are removed from the Docker, and also Docker is like platform independent. So you can also ship the Docker to this VM, uh, private cloud, public cloud, your own laptop, or any other. and any other platform. Now, how let's compare directly here with some important points. So here I have listed down few points which I have already covered few minutes back. So virtual machine has its own entire OS, maybe in GUIs generally. Containers is like it has a single OS and uh, can host multiple containers. May consume MBs of space generally. So VMs may take specifically like several minutes to completely boot up and make the apps running, OS running, whereas containerized applications can be started in almost instantaneously because it is hosted using a single OS and very few kernel features are required for that. Now limitations in case of platform support, we have like currently like what we discussed for the applications, like it is very specific to the VM, and there are a lot of uh, issues like shipping to other platforms, whereas it supports multiple platforms and it is easily shippable and scalable. Now, what are the real benefits of the Docker is like return of investment and savings. So it is like providing a lot of saving on the infrastructure maintenance. So only the only the infrastructure required can be used up and can be used in an efficient way. So maintenance is easy. We don't need extra maintenance staff. So those things can be reduced. Standardization. So now with this we can standardize our environments, and like we can have a consistent Docker container which can be run anywhere. There will be no complaints like this runs on my machine and not on that machine. We can have a consistent CI/CD. So with this we have already discussed like how we can have consistent CI/CD. CI efficiency is like faster build and deployment. So we can run multiple non-dependent steps in parallel with. So this is enabled by Docker, simple and fast. Now, users can take their configs, put in the code, deploy without any problem. So it is very fast and lightweight. So within a few seconds or minutes, it can be a Docker container can be created and deployed. It creates container for every process and does not require any reboot of the OS and etc. So those things are already gone from the container. Container can be created and it can also be destroyed easily, and it consumes a very less space compared to VMs. It supports multi-platform, which we have already discussed a few minutes back. And now comes the security part. Now, the complete control, we have complete control over the traffic and management. So no Docker can look into processes running inside a container. So every Docker container is running separately and can have a separate namespace. And none of the Docker or which is not running in the same space can peek into other one what they are doing and can expose their features or applications. Every application run on containers are completely isolated. Now coming to the Docker files and hub. So what is Dockerfile? Dockerfile is basically a text document and which contains all the commands a user can pass and call it via command line to assemble an image or Docker image. So Docker file is like D should be capital and other letters should be small, and it should be exactly DOCKER FILE, and there should be no space like I've just used for the definitions. We'll see that in the practical part. Uh, Before coming to that, like Docker has a Docker engine for, and we interact it via uh, command line, which is the Docker CLI, which will also be installing the practical sessions. Coming to the Docker build, so Docker build is like it can be used to create an automated build or during the CI/CD, or you can also use execute the command which executes the commands in sequence which is mentioned in the Docker file. So Docker builds an image automatically and reads the instructions line by line from a Docker file. Now, what is Docker Hub? So it is a cloud-based hosting service or registry, you can say, from Docker, which provides the capabilities for public and private content hosting. That is, the images can be hosted there. It helps in easy collaboration and Docker within Docker community, or you can use within your own team or company. So these are the few very basic commands which we'll be using on daily basis or are used by the DevOps or the dev team basically regularly. So Docker run. So Docker run, what it does is like it will run the command in a new container. So whatever you pass after Docker run, it will be creating a container and running in it. Docker start is for starting one or more stopped containers. Docker stop is for stopping one or more running containers. Now Docker build, like which we discussed in the previous slide, like this is the exact command which we will be passing for to the Docker file for creating a build or an image from it. So Docker pull is used for pulling an image from the repository or registry. So what we discussed in previously was the Docker Hub. So from there it will check for the image if it exists and it will download from there. So push is again pushing to your own registry or repository of the Docker Hub, or if you have your own registry, like in case of Amazon Cloud, you have ECR, so you can store it there or pull from there. Coming to the Docker export, so basically it is used for exporting the file system uh, from the container to your uh, or local host, or from the local host or your uh, container. So it's vice versa. So Docker exec is like it runs a command in a running time container. So whenever you pass the command using Docker exec, it will run a container, and at the runtime it will run the command. So Docker search is for searching for the images in the Docker hub. Docker attach is again for attaching to the Docker container, similar to the you can say a Docker uh, run or exec. So we'll see all these things in the practical part. Docker commit is for creating a new image from the containers image. So if you have some kind of container and you make some changes, so you want the changes to persist. So for that you can commit using the Docker commit. So it's just similar to your any other version control, like in case of Git, it is Git commit. So it's the same thing. So this is the, you can say, the basically the life cycle of our Docker system on the daily basis. Like what developers does is like he will download the source code from the repository, and there we may be having some Docker file, or it can also be without like the source code repository. It can be a file in your local laptop or workspace. So there you define the instructions and you build it. Once you build it, it goes and the Docker, with the help of Docker engine, it creates the container image, and the container image is then, like if we have configured the registry, it will and we pass the push command, it will push the image to the Docker container image registry, and then it will be available to your team or the Docker community, and from based on whatever is your need or requirement, and from there we can we have our own hosting, like if we have the private cloud, public cloud, your or any other machine. So there you can just configure the registry, and you can just pull the image and run the image here. And similarly from the hosts, you can just search for the images in the registry. So these are the references from which I have created the slides and this tutorial. Thanks for joining.